So in this video, we're going to build on the last two videos. We're going to look at salts, those are ionic compounds, and we're going to learn how to tell whether a salt is acidic, basic, or neutral. So I'll go through a few and then I'll give you a few to try. So here is one, so lithium chloride. So lithium chloride, well, the ions involved are the lithium ion and the chloride ion. We know that the lithium ion, like all cations, will tend to be acidic unless it comes from a strong base. And of course, lithium comes from lithium hydroxide, so that's a strong base. And we've already seen that strong bases, the reason they're strong is that they don't react backwards. And so the lithium ion that forms when the base dissociates doesn't get to act like an acid, which means that it is going to be neutral. So the lithium ion itself is going to be neutral. Now if we look at chloride, chloride comes from a strong acid. So there are those 5 or 6 strong acids that you should know. Hydrochloric acid is where chloride comes from. If it was from an acid, we would expect it to behave like a base, but if it comes from a strong acid, the back-base reaction doesn't occur. That means that chloride is going to be neutral. And if you've got a neutral cation and a neutral anion, you can probably guess that the overall thing is going to be neutral. If we look at another one, so let's look at something like iron 2 bromide, so FeBr2. Is this acidic, basic, or neutral? And again, we play the same game. So we've got iron 2 and we've got bromide. And let's go ahead and start with the iron 2. So the question is, cations are typically acidic unless they come from a strong base. And iron 2 hydroxide is not a strong base. It's not sodium, lithium, potassium, strontium, magnesium, calcium. So that means it's going to be acidic. Now, if we look at bromide, bromide is an anion. Anions are typically basic, think things like the hydroxide ion. But in case of bromide, it's coming from that strong acid, hydrobromic acid, and that reaction can't go backwards. Once the HBr breaks down, the Br- can't act like a base and reform, so that means it's going to be neutral. And then, of course, if we've got something that's acidic and something that's neutral, the neutral one you can kind of ignore. The acidic one makes the whole salt an acidic salt. So if you threw iron 2 bromide in water, it would presumably lower the pH. Okay, so we'll go ahead and look at a couple more examples. So if we had something like KF, so you've got K plus, you got F minus. K plus is coming from the potassium hydroxide, the strong base, so that means that it's going to be neutral. F minus is not coming from a strong acid, so it's not coming from that list of 5 or 6 strong acids, therefore it must be a weak base. And so if we've got a neutral side and a basic side, the whole shebang is going to be basic. Okay, so here's some for you to try. So here is aluminum chloride, potassium nitrite, lithium nitrite, and maybe one more here. So something like maybe iron 3 bicarbonate. So have a go at these and see if you classify them as acidic, basic, neutral. All right, if you're back. So, okay, so let's go through this together. So aluminum is a cation. Cations are typically acidic unless they come from a strong base. So aluminum does not come from a strong base, therefore it is going to be acidic. Okay, we can go down the list actually. Potassium comes from a strong base, potassium hydroxide. So that means the potassium is going to be neutral. Lithium is coming from a strong base, so it's not going to be acidic, it's going to be neutral. Iron doesn't come from a strong base. Iron hydroxide is not strong. Therefore, it is going to be an acidic cation. So remember, cations are either acidic or they are neutral. Now, if we look at the anion side, so starting with the top one, chloride comes from a strong acid. Therefore, it's not a base. It's going to be completely neutral. Nitrite doesn't come from a strong acid. HNO2 is not a strong acid. Therefore, it's going to be basic. Nitrate comes from nitric acid, so it's a strong acid. So that means it is going to be neutral. Bicarbonate does not come from a strong acid that I recognize, therefore it is going to be basic. And then we can just kind of combine. So the top one here, aluminum chloride, you got an acid and a neutral salt, so it should be acidic. In fact, it is fairly acidic in solution. Potassium nitrate, it's going to be basic. Lithium nitrate, that's going to be neutral. And here's a tough one here. So is it acidic from the iron or is it basic from the bicarbonate? So it turns out that we are unable to determine. In fact, we'd have to compare the Ka of iron to the Kb of bicarbonate. And if Ka was bigger than Kb, then we would probably go ahead and assume it's going to be acidic. However, if Kb for the bicarbonate was bigger than Ka for the iron, we would probably consider this to be basic. At least that's probably the best guess we can form here. Did you get him? Nice job.